Hi, welcome to my video on evaluation limits with absolute values. So before we start, let's recall the definition of absolute value. So the absolute value of x is, let's do it in two parts. The absolute value of x is x when x is greater than or equal to 0. And the absolute value of x is negative x when x is less than 0. So we have the absolute value of x plus 4. So this is x is approaching negative 4 from the left side. So the left side is similar to less than 0. So we have the negative of this. So that means the limit as x approaches negative 4 from the left side is the negative of x plus 4 divided by x plus 4. So the limit as x approaches negative 4 from the left side, they cancel out, you get negative 1. So that limit as you approach from the left side, the answer is just negative 1 because there's a constant. And on a horizontal line, no matter if you're going to the left or to the right, the value is always negative 1. So let's have a look at number 2. And again, recall we have an absolute value. This is the definition. And here we have to look at the 3 subtract x. So 3 subtract x is the same as negative x plus 3, which is the same as the negative of fx minus 3. So 3 minus x, descending order, negative x plus 3. Remove the negative out, we get an x minus 3. So that means we can now rewrite this as negative of x minus 3. Not doing the absolute value yet. Now, because we're on the right is greater than, similar to greater than 0, we just get that value of x. So, because we're on the right, but notice that this is, if you take 3, this is on the right, so that means it's positive, but this number is negative right now. So let's pretend you took a 5. 5 is to the right of 3. If you put 5 in here, you get 3 minus 5. That's negative 2. That means the absolute value is going to be a 2. So this number right here is really a negative. So that means we have to use the negative x. So that means the limit as x approaches 3 on the positive side is the negative of this expression. A little bit tricky. You just got to be careful. So when we do that, a negative and a negative becomes a positive. The x minus 3's cancel out. That gives us a 1. So the limit as x approaches 3 on the positive side is a 1. So this cancels out to be a 1. So the limit as you approach 3 on the positive side, the answer is a 1. Okay, and that's 2 done. Let's just do another one very similar to that, only we have a little bit of x squared minus 1. We have an absolute value, but we have a quadratic here. So, again, let's look at the limit as x approaches 1 on the negative side. And as we said, with the absolute value, I'll bring it back. If it's on the right side, it's x. If it's on the left side, it's the negative x, or the negative of the expression. So since we're on the left side, it's x squared minus 1. And this is on the left side, so this becomes the negative of x minus 1. And so let's factor that quadratic and see what happens. X squared minus 1 is the difference of 2 squares. It's x plus 1, x minus 1. And that's the negative of x minus 1. And we simplify this, the x minus 1's cancels out. So I get the limit as x approaches 1 on the negative side. it's x minus 1 divided by negative 1. And so that's the limit as x approaches 1 on the negative side. Divide negative 1 into x and plus x, we get a negative x minus 1. So we're approaching 1. So that means we have a negative of 1 minus 1. So that's negative 2. So we're approaching 1 on the left. We did the left right here, which is the negative. Now we take the 1 and sub in, we get a negative 2. So that's some extra problem working with the absolute value on the limits, approaching at a value of some value. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.